Good morning, Year 10. Just going to continue with Algebra 5 from the textbook. Going to move on to solving factorised quadratics today. Previous lessons we've been focusing on factorising, but now we have to make it a little bit different where we're solving equations or quadratic equations. So the main objective today though is to understand some mathematical logic to do with solving quadratic equations. And if you understand that logic, then this topic will be relatively straightforward. And it's just going to start off not with a quadratic, but with an equation a times b equals 24. And then just asking you to think about what could a and b be equal to. So a times b is equal to 24. Now, there's lots of possibilities. It could be, for example, 1 times 24. A could be 1, b could be 24. Could be 2 times 12. Could be 3 times 8. Could be 4 times 6. Could be even some of these in reverse, where a was 6 and b was 4. So 6 times 4, 8 times 3, 12 times 2, 24 times 1. Are there any other answers that I missed out? Like I say, yeah, lots of them. Okay, because solving equations, the answers don't have to be whole numbers. They could be negative numbers, could be decimals. You could have something like minus 2 times minus 12. That would work. You could have minus 12 times minus 2. That would work. You could have 2.4 times 10. You could have all sorts of different things. You could have 100 times 0.24. And that would go on forever. And I could write different solutions for a and b, and they'd be infinite amount, and I'd never be able to write them all down on paper. Now, let's consider though the equation a times b is equal to 0. Okay, a times b is equal to 0. All I've done is change it from a 24 to a 0. What answers could this be? Well, you could have 0 times 0, I guess. That would give you 0. What others could you get? You could get 0 times 1, 0 times 2, 0 times 3, so on. You could even get some of these in reverse. 1 times 0, 2 times 0, 3 times 0, that would go on. But again, it doesn't have to be whole numbers, it could be negatives. So you could get 0 times negative 5. That would work. You could have minus 5 times 0. Reverse it. You could even have some decimals. 0 times 3.8. You could have 1 million times 0, and so on. Again, there would be infinite amount for this. However, there's not as much freedom with a times b is equal to 0. Because if you look at it, when the answer is equal to 0, in every single one of these, there's at least 1 0. Every single one of these, one of the numbers, at least one of them is going to be 0, otherwise it's not going to work. And that is the main logic you need to be aware of today. So if you have to solve a times b equal to 0, then either a is equal to 0 or b is equal to 0. And that is the logic we're going to use today and apply that to quadratics. Right. Let's take this quadratic x plus 2, x minus 3 is equal to 0. Now, how can I use the logic from above? Well, it's equal to 0. It is a product. Something times something equal to 0. So I can use this rule. If something times something is equal to 0, either the first thing is 0 or the second thing is 0. So either the first thing, which is the entire bracket x plus 2, or the other thing is 0, in this case the second bracket. It's the only way that can be true based on the logic from above. Either the first number is 0 or the second number is 0. And then you end up with two mini equations which you can solve. This mini equation, subtract 2, x could be negative 2. This mini equation, add 3, x is equal to 3. Okay, so got two different answers actually for this. And remember, when you solve equations, you can always substitute the answers in to check to see if they work. If I picked on 3, we could have 3 plus 2, bracket 3 minus 3, and is equal to 0. You can check your answers. And that's pretty much the logic today. So you're going to get factorised quadratics. And that's one of the big uses of factorised quadratics, or the big use of factorising, is it allows you to solve equations. Okay, you need to write stuff as products, something times something, in order to make use of this logic. What about this one though? X minus 5 squared is equal to 0. What about this one? How can I make this one look similar to the other ones? Well, firstly, it's equal to 0, which is good news. If it was equal to anything else, it wouldn't make sense to do anything at all. And there's a trick to this. Remember, something squared, that is the same as doing x minus 5 brackets x minus 5. And now you're left with something which looks very similar to the thing above. There's a times sign, is equal to 0. And you can use the logic from above, which is either the first number is 0 or the second number is 0. So either x minus 5 is equal to 0 or x minus 5 is equal to 0. First number equal to 0, second number equal to 0. With this one, I actually give you the same answer. There's only one answer for this. It repeats. X is equal to plus 5. Solve this one, gives you the same answer. X is equal to 5 again. Okay, so that is it. I'm going to give you an exam tip to help you out. So, let's think about this. This only works if the quadratic is equal to 0, then you can use the logic. Okay. A few things I want you to practice now. So if you find page 319 in the textbook, you can do both exercise 8 and you're going to do 8 star. You can use the answers in the book to mark your answers, and then you are going to upload them to Class Notebook so I can see that you are doing it correctly. Thank you very much, and I'll speak to you soon.